If they want to help the environment, start learning about their local recycling system and understand that the hype isn't just bioplastics, the hype isn't just banning plastic. It's not about peer pressure and whoever's the loudest, whoever's the most radical will win, but really think about the ideas on the table and learn more about different solutions, because there's so many different types of technologies, and these different technologies work for different regions. It's really a solution that is case by case. You have to look at the use case of the plastic that's created and the technology that is used to recycle it.
Welcome to SheEO.World, a podcast about redesigning the world. I'm your host, Vicki Saunders. In each episode, you'll hear from SheEO Venture founders, women who are working on the world's to-do list. These innovative business leaders are solving some of the major challenges of our times. Sit back and prepare to be inspired.
My name is Miranda Wang, and I'm the co-founder and CEO of BioCellection.
I'm Jeanny Yao. I'm the co-founder and COO of BioCellection.
Thank you very much for joining us today, you two. We're really excited to hear all about the crazy journey that you've been on since you met way back when. And so maybe I'll start with you, Miranda. How did you two meet, and where did the idea for BioCellection come from?
Jeanny and I met in 8th grade at high school at a recycling club meeting. The two of us were actually new to high school and looking for great after-school activities to get involved in. And both of us chose the recycling club, where students were responsible for ensuring that plastic bottles and cans are actually getting recycled. So we met each other, and that was where, we started what is now about a 10-year relationship and building multiple organizations together. When you're through so much, it's sort of like a familial relationship at this point, not just working together, but helping each other in our daily lives. We've moved to a totally, in terms of Jeanny, to a totally different country. And, for me, to a totally different state after college, because I did college in the U.S. We had periods where we really were the only people around that we knew very well. And going through those periods together has just been an incredible journey and incredibly strengthening our relationship.
So from grade 8 to co-founding a company, Jeanny, tell us a little bit about what is BioCellection?
Yeah, BioCellection is an innovation startup in chemical recycling of plastics. So our mission is to use technology to valorize plastics that are currently waste and contributing to pollution. And how we do it is that we develop advanced chemical recycling methods to turn this plastic material, this packaging waste material, into valuable chemicals and performance materials that not only have higher value than plastic packaging to begin with, but also stay in the economy longer because they're used as performance materials like in people's cars and electronics and textiles and apparels, rather than packaging that is used, for a few minutes and discarded by the consumer.
Why are you passionate about this? I mean, clearly you've been passionate about this for a long time, starting with Recycling Club in grade 8, which is where all great companies should be founded, I think. I love it. But why are you passionate about this issue? Why does it matter so much to the world right now?
Both Jeanny and me, it's a pretty deeply embedded belief that if humans want to continue living on this planet, we have to solve the plastic pollution problem, and we have to do it within this generation. It's really obvious that right now, plastics are being found as pollution in every single part of the food chain. What we think we're putting in a garbage can and is going away forever could end up in the middle of the ocean just because of the way the scrap waste industry, the waste is being exported to poor countries that don't even have recycling programs and infrastructure. This is a horrible problem, and if anything, it illustrates the social inequality globally. It's kind of like, I would say, the ugliest side of the global trade and globalization, because waste is something that is, you could have places, say in California, where we have pretty clean beaches, and then you go to places like Indonesia, and the pollution is everywhere, and they have the densest biodiversity in the oceans. It's clear that this plastic, no matter how amazing of a material it is, has no place in our environment. And what BioCellection is doing is we're turning this challenge into a bigger opportunity. From the perspective of what do we do, a lot of people are advocating for banning plastics to reduce it. We're in favor of that as well. However, we believe that, given that right now over 340 million tons of plastics are produced globally, and the plastic industry actually projects this number to double in the next 15 years due to global population increase. And if you look at what the single-use plastics are even being used for, a lot of it is being used to protect food and water in places, for example, like Haiti, where they don't have clean drinking water coming out of pipes. Like these packaging, no matter how polluting they are, they actually do have a very major important use in that 10 or so minutes they're being consumed and the shelf life that they provide. So the question is, if we have to make these plastics and we're going to be making more, what can we do to prevent this plastic from becoming this terrible pollution after it's being used? And the answer that we came up with is to continue innovating and developing a technology that can take this plastic once it becomes waste and then upcycle it in a way that, right now no one knows how to do. We specifically target plastics that are unrecyclable right now, so specifically low density polyethylenes. So these are plastics like things that would make up your plastic bags or wraps, cling wrap, pallet wrap. So both consumer packaging and plastics used in different parts of kind of the background of the supply chain. We take these plastics, we break them down completely to their essence, so to their chemical building blocks, and then we build back up, not to the same plastics, but to higher value performance materials that can be used in advanced manufacturing and turning them into materials that can be used for many, many years. So this, in our opinion, is the solution. It doesn't only cut pollution in the end, but it also, by circularizing these molecules in this circular economy, we're able to reduce the amount of fossil fuels and the carbon emissions that are created in producing these chemicals traditionally, and also in making these performance materials. So there's multiple benefits. We believe that this solution is inevitable.
I just have a question. I mean, you just mentioned it, and I was going to ask a little bit about the circular economy. This is for either of you. Do you view yourself as part of the circular economy? Is this the future that we think we're going towards?
I think that the current circular economy is mostly about turning, the same type of plastic back into this same material, right? To be able to circularize it so you don't have to extract virgin oil to create this packaging. But we see ourselves as contributing to a new type of circular economy because inherently plastics are coming from petrochemicals and they're stuck in this cycle of technical materials, right? So plastics can only make things that are plastics or fuels or of the sort, right? Things that are used in the industry and supply chains. And then there's this whole other cycle of biological materials that people are creating, like bioplastics, and then those things would break down. But there's no overlap of the two right now. Traditionally produced plastics are not able to enter the bio cycle to be turned into compounds that can essentially break down at the end of life. So what we're doing is really interesting because it's taking a traditional technical material and turning it into molecules that can actually feed into both the technical cycle and the biological cycle. So, for example, the output of our novel chemical process is a group of chemical building blocks, as Miranda said. These are called dicarboxylic acids. And these are actually biological compounds that humans create in our bodies. So these are breakdown components of certain types of sugars. If you release these compounds into nature, or if animals ingest certain amounts of it, they're actually biodegradable. They're perfectly harmless in nature, right? So they can break down. They can also be used to make biological compounds, like they're used in the food industry as additives. They're used in pharmaceuticals as additives. They're used in personal care and cosmetics, right? So that's a totally biological path, right? Because eventually at the end of life for these types of products, you don't really generate any waste, or it's waste that you can put down the drain and that's fine. these chemicals can also be made into things I was talking about earlier, such as performance materials. So these are back into the technical realm again, but in a higher value chain. So these are performance materials like nylons and polyurethanes. These are essential for building homes and cars and even airplanes. They're really high quality, high functioning things. And they're the building blocks of these higher grade materials. And the way that we're doing this circular economy, with the way we're recycling the molecules, is we're not breaking down the plastic packaging into the same monomers that create the low value technical plastic packaging, but we're transforming these small molecules into versatile chemicals that can feed into so many different applications in both technical and biological cycles. And they have so high of value, final value, that the margin created from that recycling really makes sense for this recycling effort, right? Mechanical recycling is not working today because there's no market for the end materials. They're so low value and they're not good enough quality that they can't compete with virgin grade plastics. So our approach is you really have to check all of these boxes. You have to make a versatile material that can go into various different applications. You have to create this end product has to be high enough value to justify the recycling cost. It has to be able to allow more opportunities in both technical and biological cycles. So that's how we see that, we're contributing to a new type of circular economy that is more beneficial because it just gives more opportunities for these molecules that are stuck in the traditional petrochemicals to be used in different parts of our economy, different parts of our supply chain.
The word transformation, and I mean, taking a product and breaking it down to actually create an even better product after it's transformed, to me is really fascinating. And a lot of the work that we talk about with SheEO Ventures, mindset shifts and like doing things a new way is one of the biggest blocks. And so Miranda, maybe over to you on what are the biggest challenges you face in going to market with what you're doing? Is it on the total edge of innovation and hard to explain to people, or what are the things that are your biggest challenges?
Yeah, I think on a communication standpoint, there are definitely challenges. Plastics, there are many types, especially when it comes to packaging materials. You may have noticed that the triangle logo for recycling has numbers in it. There are actually numbers 1 to 7 when it comes to everyday packaging. The 1 to 7 actually represent 6 major types of plastic materials for packaging. But each of these different materials are built of completely different chemical structures. So, for example, what would make a clear water bottle like PET is a completely different chemical structure than what makes up a plastic bag, which is PE. And that's usually number 4, this low density, or number 2, this high density. With these two types of plastics, what is really challenging to communicate is that although they both look similar and feel similar to a consumer who's holding it, PET, the clear water bottle type of plastic, is actually really easy to recycle. We have always had mechanical and also now chemical ways of breaking down that plastic and recycling it. And that's due to the chemical structure enabling pretty easy fixes for it to be recycled in a circular fashion. However, with polyethylene, so things like plastic bags, because of this chemical structure, it's really difficult to recycle, both mechanically and chemically. So it's really difficult to recycle mechanically because you can imagine a plastic bag that has grease on it. You just can't shred it, clean it, and melt it and turn and mold it into something that has enough strip. Whereas plastic water bottle, if you shred that, you can turn it into a polyester shirt because it's essentially the same material as what is in a polyester fiber. It's a little hard for people to understand that these two materials have pose totally different technical challenges when recycling. And because of this, all of the companies that are claiming to be using post-consumer recycled plastics are only using the PET or the water bottle type of plastic. And people think that, that is closing the loop, but it's not, because there are 5 other plastics, numbers 2 to 7. The 7th type is sort of a miscellaneous group. But there are 5 other main types of plastics that are not in the picture right now. And those are the plastics that are causing the ocean pollution. Those are the plastics that right now we have very poor economics justifying the recycling for. Whereas the PET plastics have always had really great waste scrap markets. So what BioCellection is creating is a solution for the unrecyclable plastics. They're unrecyclable because the current mechanical means to recycle them do not yield a quality product that people can sell at a profit. So nobody is recycling those. And we believe that this problem is largely due to a lack of, technology allowing a higher value product to be created. So we have been targeting this. So the challenge has always been, how do we communicate with it to a consumer at the end of the day, where we make a, performance material that's made from trash bags, from polyethylene, and somebody else makes a t-shirt that's made of polyester from recycled water bottles. But the total experience, the challenge of doing both of these things are completely different, right? They're completely different. And what we're doing is actually something that contributes to closing the gap and solving the pollution problem by either preventing materials that would otherwise go into the oceans or landfills from getting there, or we're actually going to be in the next phase working with groups that actually recover these materials from the oceans. It's a question of how do we communicate this to people out there so that people understand that, it's the stuff made from recycled PE or polypropylene or polystyrene that are really, really solving the problem. Whereas recycling a PET is, I wouldn't say is a greenwash scenario because it's still valuable. It still needs to be recycled. But it's by far right now the only thing that we talk about when we talk about recycling plastics, and that needs to change.
Just to dig in on that for a second, though, is the consumer isn't actually your customer, is it? You're going directly to businesses?
We're B2B. We are sort of in the middle of two different industries. We have two groups of customers, and currently they're both business type. So on the front end, we are a recycling service. So we'll take these unrecyclable plastics and recycle them for a fee. Currently, waste plants and recycling plants, when they cannot recycle these plastics, they take them to the landfill and pay the landfill a tipping fee to just dispose of it. So they would rather pay us the same amount to get it recycled sustainably. So that's one group of customers. So they're, waste plants, recovery plants, and usually they have a contract or relationship with the city government. So that group is the upstream set of customers. And then we have this process that turns this waste into products, right? So these are chemical material products. So we're selling to downstream material buyers. So these are people who would buy 3D printing filaments or really high-grade nylon pellets to do molding for a car part. Or it can be something that is more consumer-facing. Maybe individual product designers can buy the starting material and create small parts for their design projects. But we foresee ourselves, in the longer term, be mostly B2B because that's where the volume comes from. We want to be turning a lot of plastics into a lot of products and be able to get these products out into the economy without having to try to sell to individuals. But the initial plan is that as we are still scaling, we will be producing small quantities in the beginning and testing these products out and putting them into the marketplace for individual designers to come and try them out and use them. That is a really great way to get started. And then we can get some validation to move into industry.
Yeah, this is part of, I imagine, the challenge of this. It's new. It's got a really interesting story behind it. It's hard to kind of show all of that whole transformation. So for example, right now with 3D filament, is any of that coming from recycled product or is that all new? Or how does that happen right now?
Yes, there are also many different types of 3D printing filaments. For the actual 3D printing filaments that you would use when you want to build a part you want to rely on, so a part that would go into a car, or maybe a part that would go into a rocket, or maybe material that you want to perform and look really good. So those things are as long as there's some type of nylon, they're not made from recycled plastics. They may be made from in some cases, you can grind down nylon and remelt it and use it. But in most cases, they're made from a virgin source. So they're made from some sort of oil or natural gas. What we're doing is we're targeting this filament material. So at the moment, we have already achieved in the company turning unrecycled plastic polyethylene into these chemical building blocks. And what we're doing right now is building up from the chemical building blocks to these performance materials. Our first targets are It was making a nylon and also polyurethane. And we're going to choose the best of either material as our first product to launch.
Let's go back to how this became a business. So take me from you finished university, you've stayed in touch throughout this. What did each of you study? And then how did this become a business and how did you get off the ground?
We did a high school science project together. And that was where we started sort of incorporating science and innovation into a technical way of thinking and solving the problem, in addition to the community awareness and all of these things that we were doing in our high school. When we graduated high school, we actually went to separate colleges. Miranda went to UPenn, where she studied molecular biology and philosophy and engineering entrepreneurship. And I went to University of Toronto in Canada, and I studied biochem and environmental science. And the reason why we were both focused on the sort of the bio realm of science was that was our initial approach to, how do we break down plastics? We were just thinking of breaking it down. Right. It'd be so great if we just break it down and it would be harmless. And we were looking at these papers on biodegradation. So that's what we did the science research project in the science fair. And we continued studying these fields in college. And then when we were, I think, after junior year of college, we found this opportunity to join a biotech accelerator, where this is where we formed the company, we incorporated, we named it BioCellection. We were still trying to use a biological way to not only break it down now, but to create some type of value. That was when we realized, nobody's going to fund a technology where you're just reducing waste but not generating anything valuable, because you need money to kind of fund that process to run it. So we were brainstorming things like, what can we make out of bio? That was the idea that we sort of started working on while we were still in school. So the last year of college was kind of crazy for both of us because we were still full-time in school. We were trying to finish our degrees last year. And then we were basically full-time working on this project, the prototyping, and we're trying to develop a business plan, and we're trying to get some funding. We applied to 20-something, 30-something competitions around Penn and Wharton. And I was basically living in Miranda's dorm half of the time, trying to attend these competitions with her and help with the research. And we ended up winning 26 competitions at Penn, where we swept up a bunch of startup grant money. That was what got us started. So we decided to move over to the Valley. We heard some friends were in this area and they were doing biotech, and it seems to be a really innovative hub where we could recruit talent, and investors are more sustainably minded. The cities are more interested in recycling. So we decided to move over here with the grant money and some angel funding that we got. So that was about just over 3 years ago. So we graduated college and moved to Silicon Valley to get started. And then as soon as we got started, we had a bio lab set up. We hired a biologist to be our scientist. And then we started touring waste plants. We got invited by the city government, and they were actually, the San Jose city has been really gracious to us. They arranged these trips for us to go tour all of the waste plants in San Jose. And then we started learning about the waste materials. And it just really dawned upon us that there's so much contamination on the plastic surfaces, and there's so much volume of plastics that we realized that the biological methods that we were working on wasn't going to work, just because it's so slow and it doesn't do well in the presence of contamination. So we had to go back to the drawing board and say, okay, what do we do now, right? What is a much more practical and feasible method to recycle these molecules, turn them into something else that's more valuable? Inspired by this, biological pathways, we were originally thinking, how do we make biodegradable compounds that can be made into other things? So we were still on that line of thinking, but we switched to a chemical method. It's a type of chemical recycling that enables us to turn a technical material into a biological set of compounds. So that's how I think our twisted journey was what actually allowed us to arrive at this innovation that other people have not been thinking about. And it's a very different and it's very challenging type of science to do. we were able to recruit a lot of help. We had advisors from industry and academia that were helping us on the project. And eventually, when we got enough money, we were able to recruit full-time PhD scientists. And they have just been phenomenal. Now, Miranda and I don't do any of the lab work and have a whole R&D team that is just, here. They're here like 10 hours a day, and they're just really committed and really passionate about the work they do.
Let me just guess on what this might look like, but you're both 25 or younger. Yeah. And you've got this team of PhD researchers and scientists working there. So how's that work? That whole age gap thing going?
I would say it took us about 1.5 years or 2 years to get really experienced at, understanding what it takes to manage them and help them be at their best. The way that I see it is not so much that, they're our employees and we're their employers, but it's really a team dynamic. We have seen is that what Jeanny and I bring to the table are completely complementary to what the typical kind of PhD inventor or scientist that we bring on. Scientists are really good at thinking about challenging questions, problems, and coming up with innovative solutions. Jeanny and I are very innovative too. It's really easy to bond on that dimension. However, scientists typically don't want to take on that risk of having an unstable income or having to go out there and fundraise and present to a lot of people and make things sort of provocative or just explain to people all the things in a way that is not difficult to understand for a 5-year-old. It's just that whole training process. It's quite specialized, actually, what founders have to go through to communicate to different types of audiences. And scientists don't really want to be good at that. They most of the time, they want to be good at science, the creation, the knowledge, and the invention of an application. Whereas on the other hand, Jeanny and I, my passion are in solving the problem. So what we care about is whatever does it take to actually be able to put this team together, to support this team, to end up reaching the people in the world who will be able to influence on this matter or some other form of resource for us to keep going. We learn over time that the relationship is a lot more successful if we have more of a flat structure, if the way that the company works is much more democratic. We provide to the scientists what they need to be able to thrive in the environment. They want a place with flexibility where they can have flexible hours, where they're trusted and not micromanaged so that they have their own schedules. And one thing that we have gotten very lucky with and finally was able to successfully implement was Dr. Jennifer Leroy, who is our director of R&D, joined at the beginning of this year. At the time when she joined, she was a product development scientist who was working on formulation of our chemical products. But it became really evident that she's really good at working with different people, and she's really good at working with scientists who sometimes may not want to communicate to others in the team, who might be more of an individual or siloed, worker. And she's really good at putting together the bigger picture for R&D and helping people figure out how their everyday work would fit into that picture and helping them set goals and managing that. What we've basically learned is, if you have a really competent scientist who also really has a passion for management, then having this person manage other scientists, and for us to really just be able to trust that our team is on route to achieving those goals, setting those higher goals, on our end, and then making sure that is being trickled down and being implemented on the daily experiments and reactions. So, it's about building up this type of infrastructure and having the right people. And that actually took us quite a while to figure out. And I think in the past quarter, we've finally gotten this optimized to a state where the team is extremely effective at achieving its goals and measuring its progress.
Jeanny, just a question for you around the vision of where you're going 5 years from now, 10 years from now, whatever your time horizon is. What is success for you? What does it look like?
Yeah, that's a great question. We've been thinking a lot about the vision. We're actually going through a rebranding process to fully have an updated representation of our identity as this chemical recycling company. And we've been thinking about this vision a lot. Our ultimate goal is to transform the way that our society currently sees plastic waste from a source of pollution to a valuable resource, to a material resource that can really fuel the rest of the economy by transforming these molecules into other valuable products. Our mission is to develop technologies and scale them up to enable this type of societal impact. 5 years from now, according to our current timeline, we're going to have a commercial facility that processes upwards of 10 tons of material per day. That'll be the first commercial facility where we have somewhat like a chemical plant, and we will source plastic waste and produce these valuable materials. But in the longer term, we really want to have this technology in different parts of the world, right? Not just in the US, but also in developing countries, and provide an incentive for people to start picking up this trash, to see it as a valuable resource, and to be able to help communities recycle. If people can start getting paid to pick up this material, they will, right? That's what we've seen with water bottles. As Miranda said, in these communities, water bottles are recyclable. They have markets, so people go and pick them up. But they leave the plastic bags and all the flexible packaging behind. But now we want to be that solution that will incentivize them to also pick up those trash. Ocean pollution comes from land, right? So if you start picking things up from your community, if you start picking things up from the beaches, that is the best way to stop pollution from entering the oceans. So our really long-term vision is to create a sustainable supply chain based on plastic waste, and have different parts of people within the current existing infrastructure for trash picking, for waste transportation, to all recognize that this is something valuable that we want to start collecting.
That's amazing. I have a question for both of you, and maybe we'll sort of end on this note. But first of all, I want to thank you very much for using your leadership in the world and your genius to be solving one of the most important problems that we have. These are women in our network that are working on the world's to-do list. I'm very thankful that you're doing this. If you had an ask of people that are listening, whether it's behavior change on their part or something that you need for your venture, what would that be? And maybe we'll start with you, Miranda.
Yeah, I think it's a time where everybody, as from a consumer angle, really begins voting with their wallet. We don't have very much more time to send a signal to the businesses out there that they must adopt more sustainable materials and sustainable practices. When it comes to how fast these new recycling innovations can scale up and make it into the market, it's all a matter of economics, right? And in businesses like ours and other recyclings for plastics, we're competing against the petrochemical industry directly. The petrochemical industry is operating on natural resources they're pumping out of pipes that are already built decades ago. They're using infrastructure and plants that have already fully depreciated. So essentially all they're paying are basic raw material costs and labor. And these prices are incredibly low, not because it's actually cheap for us to get those resources, but because it's at a cost to the environment and it's at a cost to social equality in most places. When new technologies like ours make these chemicals or the downstream performance materials, the price points, the goal that we have is to match their ballpark. But in the beginning, there has to be some sort of a pull from the market where people really recognize that, hey, what this company is allowing us to now finally access and buy was actually really hard for them to get here. And what they're doing now is actually benefiting the world by cutting our emissions and reducing our pollution. And so we must support that. This type of pull from the market that allows any kind of, adoption that we see in our supply chain to move faster, and any kind of financing that we can get from potential, whether it's equity investors or debt financing, to give us an opportunity when we still have different kinds of technical risks and scale up risks involved. It's really important for everybody to recognize that it takes time, right? Like once as a population, we decide we want these things, businesses sort of need to realize it and then choose the solutions, the technology providers that can help them get there. So the earlier that everybody really spreads that awareness, the easier it'll be for us to make that transition as a whole.
Jeanny?
Education on the different types of plastics and the recycling systems regionally is very complex, but it's something that consumers would really benefit from. If they want to help the environment, start learning about their local recycling system and understand that the hype isn't just bioplastics, the hype isn't just banning plastic. It's not about peer pressure and whoever's the loudest, whoever's the most radical will win, but really think about the ideas on the table and learn more about different solutions, because there's so many different types of technologies, and these different technologies work for different regions. It's not that bioplastics are not good or pyrolysis is not good entirely. It's really a solution that is case by case. You have to look at the use case of the plastic that's created and the technology that is used to recycle it. So depending on where you are, right, supporting the different types of technologies will look different. So for people who really care, especially the activators community, I know lots of folks are based in California. Follow us and follow the policies that are going on. We have really great relationship with San Jose City over here, and we are presenting to lots of waste conferences with them. And this is something that is going to influence the other states. All of the regions are at different stages of technology with their sorting, right? So our technology is going to spread in the country in a different way based on regions. So based on where you are, you can really get involved by learning about your local policies and recycling systems and what technologies are available. And if you're in California, definitely follow us and keep updated.
Awesome. Well, thank you very much for your time and good luck building this out. I know that you're going to create a market for this. We're so excited to learn so much more about what you're up to. So thank you for your time today, and take care, you two.
Yeah, thanks.
Thank you, Vicki.
Thank you. Thank you for listening to the SheEO.World podcast. If this conversation resonated with you, please share it with a friend and subscribe on your favorite podcast player. If you'd like more information about SheEO, please visit us at SheEO.World. That's SheEO.World.